This video covers section 3.2, which is titled correlation. So what they're going through is vocab that has to do with correlation. They start with the idea of association, which is when you're looking at a graph and being able to identify essentially the slope of the scatter plot. So if it's increasing, that means it's going to have a positive association. If it's the points are decreasing, that's going to have a negative association. And again, the association, think about it in terms of the slope of the graph. So the correlation coefficient has essentially two parts. One part is that association, whether it's a positive association or a negative association. The other part is the strength. So if I have a strong correlation, the correlation coefficient is going to be a number that is close to 1. If I have a strong positive, that's going to be close to positive 1. If it's a strong negative correlation, then it's going to be close to negative 1. So this is always described on a continuum. So R is a value somewhere between -1 and +1. If it is -1, it has a perfect correlation, meaning I can draw a line with a negative slope that connects all the points in the scatter plot perfectly. If it has a correlation coefficient or R value of 1, that means it has a perfect positive correlation, so I can connect the lines with an increasing slope, or connect the dots with a line of increasing slope perfectly. So there are no hard and fast rules about the different words that we're going to use to describe the correlation. So remember that if it's 0, there's no correlation. Then numbers that are closer to 0, we would call a weak correlation. As we move closer to 1, it's becoming more strong. So then we would have some moderate values in the middle there. And then finally, we have strong correlations as we get closer to 1 or -1. So there's no numbers that they give. It's not like between I don't know, 0 and plus or minus 0.3 is weak. There's no values like that. It's really kind of relative, so that's part of what makes this a little bit more complicated. So the next thing we're going to do is just kind of look at some visuals with that correlation coefficient. So what R values look like on a graph. So a perfect correlation that is positive would look like this. Again, I can connect all those points with a perfectly straight line. And so that's why it is a perfect positive. If my correlation coefficient is 0.8, that's a positive number. So I know it's going to be a positive relationship. That number is also close to 1, so that means it's going to be strong. Again, the tighter the points are here, the more strength the correlation is. So then as I get closer to 0 with a correlation coefficient of 0.6, notice my strength it's getting wider, so it's getting less strong. So I would call this a moderate, because remember, moderate's in the middle, so numbers within the middle of 0 and 1 would be an indicator of moderation. And it's still a positive number or positive slope, so this is still a positive relationship. Next, they show us what no correlation looks like. So if the correlation coefficient is 0, as one value increases, there's no tendency for the other value to change in a specific direction. I cannot distinguish a pattern here to create a line that is positive or negative. And then as we move past 0 into the negative values, if my correlation coefficient is -0.6, notice that these points are spread out, but still in a decreasing direction. So this is going to be a moderate negative now relationship. if I have a correlation coefficient of negative 0.8, 0.8, negative 0.8 is closer to -1. So that means that that's becoming strong. Since it's negative 0.8, again, that gives it a negative relationship. And then finally, they give us a -1 correlation coefficient, so we can see what a perfect negative relationship looks like. One thing to note is that correlation is not a resistant measure of strength. So that means that outliers affect the correlation. So outliers are unusual observations that can affect the strength of the correlation. So outliers are values that don't fit the pattern, right? In scatter plots, we also talk about something called high leverage points. Those have a much larger or smaller X value than the others in the data set. So if they're falling within the pattern, they're going to strengthen the linear relationship. If they fall outside the pattern, they're going to weaken it. So let's look at a visual and talk about what outliers look like versus high leverage points. So if I look at the data, it's fitting between these two lines, right? So I can predict that values will fit between those lines, and as I move on, as I increase study time. If a dot is outside of those lines, it could be an outlier or a high leverage point. Okay. Outliers will always be outside those lines, or unusual observations will always be outside those lines. High leverage points could be within the lines. They have another factor where I'm identifying it. So the way that I tell if something is a high leverage point, since it's looking at the X values, what I want to look at is where do my X values lie within the pattern. So I'm looking at this. So my X values look like they go mostly between 0 and 8, right? And so a high leverage point is something that has an X value that's much larger than the X values in the data set. So yes, 8 is past our X values that are given, but that doesn't make it a high leverage point because it's not much larger. So that would mean that A is the high leverage point. Okay, so A is outside of that pattern of the data, but more importantly, its X coordinate is way larger than anything else that's in the data set. Which means that since B and C are close to the data values, but in terms of their X coordinate, but they're outside of the pattern of the data, that means B and C are unusual observations or outliers. The last thing that they talk about in this lesson is correlation compared to causation, right? So if I'm studying something, I want to determine if my explanatory variable causes my response variable to change in a particular way. And so remember that this correlation shows a pattern that provides reason for you to go further into a study. However, we can't guarantee that it means that that explanatory variable is actually explaining the response variable. So they just want to make sure that we keep that in mind as we're doing these problems. So again, lots of vocab. We're building into being able to use some technology and values in the next couple sections.